For decades, the technology world chased a single matrix to keep Moore's law alive. The smallest possible node we could use to print a transistor. But as we reach the physical limit of shrinking silicon, the rules of semiconductor industry have fundamentally changed. Today, the ultimate bottleneck for the future of computing isn't just whether the chip is printed on a 5 nanometer, 2 nanometer or 1 nanometer node. It is how that piece of silicon is stacked, wired and sealed. And that is where the semiconductor packaging is required. A raw silicon die is incredibly fragile and entirely useless on its own. It needs a way to communicate with the outside world. Packaging acts as a crucial bridge between the microscopic silicon die and your device motherboard. But did you know historically packaging was treated as just a plastic shell with metal pins holding a single chip? But as Moore's law slows down, it is becoming physically and economically impossible to keep shrinking transistor on one massive piece of silicon. To keep performance doubling, the industry has shifted to advanced packaging, which we called as system in package. Instead of manufacturing one giant expensive die, engineers are adopting a chiplet-based architecture. That means manufacturing smaller specialized dies called chiplets for specific functions like memory, logic, and I/O. Then using a 3D integration to stack these chiplets vertically or side by side on a base layer called a silicon interposer, and finally connecting them with a microscopic internal wiring so they can act as a one unified incredibly fast processor. This modular approach allows hardware company to mix and match components, and this dramatically improves manufacturing yield and bypass the physical limits of the traditional silicon, and it's ultimately unlocking the massive bandwidth required for the future of technology.